Hi, good afternoon, everyone. It is my pleasure to introduce you to our speaker, David Schroederer. David Schroederer is a veteran Silicon Valley executive and entrepreneur. He is presently on leave as the Semantic Technology Network Editor-in-Chief, where he oversaw corporate data protection technology and system security technical publishing, as well as a monthly newsletter distributed to about 120,000 global readers. David has a master's degree in applied mathematics from the California Institute of Technology and an MBA from the University of Southern California. Whenever possible, he lectures at universities such as Stanford and MIT and immerses Silicon Valley companies in his favorite subject, innovation. David has authored 10 technical books and 6 commercial software programs for a variety of computing architectures using several different languages. His soon-to-be-published 11th book follows 10 years of research and is titled Innovation Survival, Concept, Courage, and Change. So without further ado, David Schroederer.
Thank you very much, Ann. Ladies and gentlemen, it's a privilege to return to Google. I have 2 thanks for this return trip. The first is for putting the aid relief request on your home search page for a few days. I deeply appreciate that and was genuinely moved. The second thing is as a published author, I was not convinced that Google's digital book effort in scanning in the libraries was a good thing. I didn't know if it was a bad thing. I wasn't convinced. I am now a full square-on proponent for it. And in fact, today, if you have not had the benefit of this particular project, you will get a benefit for it immediately. So perfunctories aside, let's move into the presentation here. This is the Google Tech Talk Innovation Survival Series. This is my second one. You see the gentleman there with the bright idea? He's got a couple of guys running toward him because they like bright ideas. But guess what? This is the early and late majority as well as the laggards. The guys that are brick red are running because they are on fire. They're running so fast and they're so afraid. And the guys that are beet red are running so fast they're exhibiting the Doppler effect. So when you're involved in innovation, if you're not ready to accept something like this, you might have wandered into the wrong tent. And that is one of the things that I talk about in my book. So let's move on. The one lecture I haven't given here is the evolution of the surfboard, and that's evolution in sports. I have studied innovation in 6 different disciplines. Here they are: sports, art, literature, music, science. Robert Kennedy was kind enough to bring me a few months ago, and I did an industry flight of the Voyager, the airplane that went around the world. It's a Google video. It's out on YouTube. Today's talk is on the military, and in specificity, it is on warship evolution. They've established that there is not a core competency here in the audience and here in front of me in warship design, and that's intentional. I take people out of their area of core competency and I show them that the things they face on a daily basis are shared because innovation is a human experience and a human condition. So this is our talk today. We're going to start off with warship, wooden warships. We're going to move into ironclads, very quickly into dreadnoughts. You may or may not be aware of dreadnoughts. And we're going to talk about warship supremacy. That's going to be about the halfway point, and we're going to be flying. And we're going to have some closing observations. To begin with, this is the wooden warship. This is the apex of a wooden warship. This is the HMS Victory. It is sitting in Portsmouth. It is the only surviving instance of this design. The first one was a Mary Rose, and it was launched, 200 years before the ship was launched. This particular ship was launched in May 7th, 1785. Notice there's 27 miles of cordage, a rope for the sails, killed 2,000 oak trees to build it. 820 people jammed onto that little puppy. They slept in shifts, in hammocks, rocking away, just having a good old time, don't you know? It was a first-rate ship. It was given that classification because there were more than 100 guns on it. These were smoothbore loaded through the muzzle, muzzle loading, and Typically, a ship would have various calibers of it. The thing that distinguished the British from the French and the Spanish was they practiced, and they practiced hard. They could shoot twice as fast as the French and the Spanish. So effectively, when it came to a French or Spanish, they had 208 guns. If you were a bad guy and this ship was looking for you, the last thing you'd want to see in the high sea was its masts, I guarantee you. Now, built out of wood, the strategic material, right, the critical thing is going to be wood for the masts. And the king would send his soldiers through the forest, and he would mark trees that were straight, tall, true, and strong with a king's broad arrow mark, 3 marks. You could be killed if you did anything to that tree. You did not touch it. Okay? After a while, very, very short while, the British forests were depleted. And by the 1700s, they were going all the way over to the Baltics looking for mass-grade wood. Well, I had these 13 colonies all across the pond, and they climbed to the top of a ridge of the first mountain chain, and as far as the eye could see, there were nothing but mass-grade trees. Mountain after mountain after mountain. It was an infinite supply of this wood here. And it was one of the reasons why Britain coveted these 13 colonies, now known as the United States. In addition, along the eastern coast and all the way pretty much down to Mexico, there was another kind of wood growing in a tree called live oak. It could sustain 100 years of immersion in salt water when properly cured beforehand, no problem. This was like nuclear reactor fuel. So Britain started cutting down these trees and shipping them over to Britain to build them, but after a while, the MBAs get involved. They say, you know what, let's offshore ship construction. It's the future. We can monetize the transit time, right? Why ship this stuff over, right? Let's build them over there and everything else. So what was the reaction for the shipbuilders over in England? They said, oh man, they're going to be big, they're going to be ugly, it's not going to work, it's going to be, yeah, it can possibly be effective. So how did it work out? Well, with all things being what they were, there were some unintended consequences of this. And then specifically, by the time the War of 1812 rolled around, the United States had built some of these guys. And they didn't have 104 guns or anything like that, but they could outsail everything in the sea. And surprise, surprise, they could outshoot the British guys. Why is that? I know it's going to come as a shock to you, but somehow those rascally, recidivist, reprobate colonists were saving the very best wood for themselves, and they were coming up with new enhanced designs. You know, they just lived far away. They weren't stupid. They just lived far away. And there's one there. That particular design there kept the boat from hogging, and hogging is when the ship goes like that, and then that's you know, bending and hogging and stuff like that. So new designs, best wood, best of class ship. So strong that that one that you saw became known as old Ironsides. And it got that name in this battle here, Battle 1812, taking on the French. And the ship that is getting the worst of it is French. It was pulverized by USS Constitution. And it was so Swiss cheese, they had to sink it and get rid of it and just sail back with the crew. Well, there was an admiral over in the UK, the British Isles, that noticed, and his name was Admiral Horatio Nelson. And he had a prediction. He says, I see trouble for Britain in those big frigates across the sea. He's a very smart guy. So let's talk about him. Battle of Trafalgar, October 21st, 1805. In the United States, we have a game called football. It's not soccer. And we call football in the rest of the world soccer here, but it was football. We had a very good, sharp quarterback. His name's Joe Montana. He says, sometimes there is no next time, there is no second chance, there is no timeouts. Sometimes it is now or never. You know, when you go over and you hit the reset button for power to bring up, you know, your big former aluminum plant switch for one of your big data centers, it's now or never. For Britain, they were fighting France and Spain. The deal was that the British had a vastly superior navy to the French and the Spanish, But the French and the Spanish had a vastly superior army than the British did. And they could take their substandard navy, sail it up to Cherbourg or Calais or whatever like that, load troops onto them, sail just across the channel, and pulverize the UK right out of existence. Failure was not an option. What Nelson did was he said, we must destroy this fleet to prevent that from happening at all cost, including the destruction of his own fleet. He was an incredible leader, and you will see this in your leaders here in Google. You're looking at a real leader, will lead from the front, they will be competent, all right? Nelson had already lost one arm, he was blind in one eye from shot, and he was a real soldier. He issued general battle guidelines. Things like, this data center needs to be operational September of this year. It doesn't say, you know, you need to go call PG&E and haggle. No. Data center needs to come up. You guys figure it out. So here's the battle. Depiction of the battle. It's beginning to unfold here. Nelson did a crossing the T maneuver, had existed before, and what he did was he sailed into the ships there on the right, which are sailing to the north, and he cut off their escape route so that they could not live to fight another day. And this is them sailing in to it, and this is sort of a depiction of what the scene looked like a few hours later, and the French are getting beaten, and beaten badly. This is a depiction of what's going on inside the deck, up on top of the deck here. You see guys with rifles. Those are Marines. In their off hours, they are keeping the motley crew in order with their rifles and threats and things like that. But in battle, they're shooting snipers that are up in the lanyards and the masts and things like that. There's a lot going on. Now, let me drop into MBA mode here. I know it's going to be a new thing for you guys. In a battle like this, there are attendant splinters. Now, when you were young, did you ever get a splinter in your finger? You know, and you went over to your mom and you said, Ma, I had a splinter, and your mom and got tweezers and pulled it out, you know, and you go, ugh, like that. Ladies and gentlemen, these are not the kind of splinters I'm talking about. I'm talking about 20-pound splinters that explode off the side of a ship after a cannonball hits it, about 30, 40 miles an hour. It weighs about 30 or 40 pounds. It's sharp as an axe. It decapitates people. It dismembers them. It eviscerates them. Their internals fall out in red, crimson, gelatinous goos on the floor. There's people screaming, people getting stapled into the walls on the other side of the ship. So I'm not going to make too fine of a point on this, but this is the real show here. How bad is it? Extraordinary carnage is going on below deck and on top deck here. Half the crew could be killed, not uncommon. All right? It was so bad that they painted the insides of the decks red to cut down on the distraction factor during battle. And because the floors got so slippery, they spread sand down so that the barefoot soldiers would not lose traction. So we're going to move on, but think about this because it's the real deal. Now, gentleman in red, that's Horatio Nelson. He took a bullet from a sniper. He died. He died not knowing whether or not he had won, but in fact he had. So, at this point in time, the HMS Victory was 40 years old, and in fact, it was 300 years pretty much after the HMS Ray, the first example of this kind of ship, was built. So there was very little evolution in a design. A design was good for centuries. Well, okay, over in the United States, going up and down the Hudson River, there was this guy, Robert Fulton, and he had been over in the UK during all these battles and things like that. And when the British won at Trafalgar, British Navy said to him, Robert, we've really enjoyed you being here. Please leave. And they did one thing that was very unusual. They gave him an export license for machinery. Very rare to be done that. And what did they export? They exported a steam engine, and he hooked it up on side paddles on a ship. And with these side paddles, he can actually go up the Hudson River against the current. Okay? This is a big deal. So is this export technology, a core competency export given away, not a good idea, right? Is this going to make any difference? Let's examine the facts. Okay, so there's a steam engine in there. You can see the black smoke coming up. Oh, look, those side paddles there, right? They sit in prime cannon real estate. They reduce the numbers. That's the sweet spot on the boat to put cannons. And they're very vulnerable themselves. You take one of those guys out, you got the whole boat, right? They're really vulnerable. So I think there's some serious business concerns here for implementing this. But there's worse. All wooden ships are inherently vulnerable to fire. They had fuel, they were burning stuff, the coaling was dirty, right? These guys had white uniforms, the cold dirt got on them, the smoke got into the, soot got into the sails, onto the decks. There weren't coaling stations everywhere, limited radius of action, things like that. Fire, the boilers could explode. But there was something much, much worse. Much worse. And I know this is going to horrify you. I apologize in advance. Excuse me. I apologize in advance. Worse. What could be worse? It disturbed the natural social order of ships. Sailing guys, there were guys way up in crow's nests and guys all the way down in the bottom of the ship and guys that put sails down and guys, boats, stuff like that. There were these new people that came onto ships. And it's the apology here. I hate to say it in mixed company, but you ready? They were engineers. They weren't sailors, they were engineers. And they looked at these glass meters, and they looked at pressure valves, and they turned things, and they stoked. And it was these engineers, those kind of people. They were there, and it's just like, the captains, they're not sailors, they're engineers. They didn't know what to do with them. This was a problem in navies for about 100 years. Do not underestimate when you introduce a new technology into a social system and it turns it upside down, the ferocity of the pushback you are going to get. Well, as an expert here, self-appointed expert, I can assure the audience, based on my MBA, there is no role for steam anywhere based on this analysis. So let's move on. Well, back in the Civil War, the crafty Americans here, they built this thing called a submarine. And if you look at the two things circled in red there, those are screws. And that's how it got around. It went up and down with the vertical one. You turn it, and it's Archimedes screw principle, screwed it up and down. And forward, you turn it, and it would pull you back and forth. So you sort of like screwed your way over the water. And this is how propellers began to be known as screws, because they were screws. Well, there were a lot of guys that were looking at it. About 27 years later, there's this guy, Colonel John Stevens, and that's a boat up there on top, and that's what his screw looked like. But it was real complicated and kind of clunky, and it didn't work well. And then there was this guy, John Erickson, incredible engineer, absolutely beautiful engineer. And he had counter-rotating, kind of like paddle screws. And what he discovered was when he removed one, everything was simpler, everything was easier, and best of all, it was faster. The same thing happened with John Erickson. Okay, so here is something you need to constantly keep in mind. If you're thinking of something innovative, you better do something about it real quick, because there were a whole bunch of people that were working on screw propellers and things like that simultaneously in different areas, independently, unaware of each other. Okay. Sir Francis Pettit Smith, he was on the Paddington Canal with his screw up there, and he hit a submerged log, and it broke his screw in half. Chopped off the back half of it. Guess what? Everything was faster. So you got to take it out, and you got to dink around, and you got to surprise, and say, well, maybe if we make the queue a little bit bigger here and drop the latency over there, maybe it'll get better. Well, maybe it will. So John Erickson takes his incredible design, and 3 years later, he goes to the British Admiralty, and he says, I got this thing. It's just going to save you guys. It's so wonderful. Do it. And that's what they say. Altogether useless in practice. Its powers applied at the back. There's no way you could steer a ship like this. And, get out. Unfortunately, 6 years later, Islamabad Bernard comes out with the SS Great Britain, which is one of the greatest landmark in transatlantic travel that has ever existed. Notice what's at the back of there. It's a screw that is very much like John Ericsson. So John Ericsson was inappropriately rejected, even though he was dead on. So now, anytime there is a transition, there are glimmers that begin to appear. And as they begin to appear more and more rapidly, you begin to see the constellation. It begins to appear. So one glimmer in warship evolution occurred in 1779, 1783, and it's a French and Spanish, once again going after Britain. Britain owned Gibraltar, great Caesar, and this was a great battle they had there. And this particular gentleman said, we can get them from the land side, but it's pretty well barricaded. What we ought to do is over on the ocean side, the Mediterranean Sea side, we should build some rafts very cleverly and put guns on them, and we can just get within cannon range and just shoot and shoot and shoot, and we can just wipe these British guys out on Gibraltar. And that was it. Jean-Claude Lenoir, le Michel Cheval d'Arcon. Merci, monsieur. So that's kind of like what it looked like. That's a depiction of Gibraltar there, and in blue here, this is an aerial view of it, and those on the upper left, those are the kind of boats that he was building. He took a regular ship, ripped everything off the top, moved all the cannons over to one side. He put some ballast down in the bottom there to keep the cannons from pulling the ship over, and he very heavily protected the exposed side. So what did they do? They built 10 of these things, 10 to 29 guns each. 5,260 guys were out on these 10 deals. They had iron bars over there on the side to protect it. They filled the areas in between them with sand because they knew the British were going to shoot red-hot cannonballs at them called hot shot, and pump water into the sand to be waterproof. They had a cover-up. I don't know. If I was a British guy, I'd be pretty afraid. All right? What do you think? Pretty good plan, huh? Yeah, park out there, invulnerable, shoot away, shoot away, shoot away. Well, how'd it work out? Well, the way it worked out was the pumps failed. So they didn't get the water down into the sand correctly, okay? The British used hot shot. One boat caught on fire. There were no provisions to extinguish any fire because there wasn't going to be any, right? The boats were moored too close together. The fire hopped from battery to battery to battery. None of the guys swam because sailors didn't swim back then. There were no lifeboats because you weren't going to need any, right? It was such a good plan. 5 batteries blew up. 5 burned to the waterline. 4,773 killed for nearly 91% casualty rate out in the sea. So what's the takeaway here? There is nothing more horrible than the murder of a beautiful theory by a brutal gang of facts. And just because you sit around and you come up with a good idea, maybe you ought to wander it out into the real world. Because we live in a multi-dimensional, fractal-based, nonlinear world with feedback loops that are subject to dislocations, discontinuities, tectonic shifts, as well as the effects of time and scale. And you get any one of those wrong, you might have a 91% fatality rate. So, projectiles, hotshot got those guys. Projectiles initially in the wooden ship days were there to destroy the propulsion, which would be the masts, as well as catch everything on fire. And here's a big long list of things here. You had Greek fire, where you shot some burning liquid out that was you couldn't extinguish, and boy, that scared the Phoenicians to death. Hotshot, Martin shot. Cannonballs that were hollow inside, filled with molten iron. You plant one of those up against a wooden ship, and boy, that's going to be a real scene there. You got shrapnel and everything else. There's a gentleman by the name of Benjamin Robbins. He says, we got rifles and, and with stuff inside to spin the bullet and make it, accurate and everything like that. Why don't we do the same thing for naval cannons? And instead of shooting a ball, let's have half a sphere in front, and let's have a cylinder mated onto the back, and we'll make it elongated, and we're going to put some real wood behind that arrow and meet some real interesting people that way. Ignored. So, but in 1823, Henri Joseph Paxson in France, he is mulling over how can we use mortar shells more effectively. Mortar shells are hollow exploding shells that get shot way up in the air, and they come down and they have fuses, and they're kind of unreliable. You know, they kind of go off sometimes and they kind of don't. But when they go off with a bang. And so what he said was, what we need to do is build cannons, thick in the back, and we have bands that are super red hot when you put them on, and they cool and you know, put in tension. Have narrow in the front. We can shoot these same projectiles in a flat trajectory. They'll stick into the side of a ship and explode and put a hole in the ship that you can drive, you know, an 18-wheeler through, or even more preferably in the context, it will enter the ship and it will go off in there and be a maximum, you know, bad surprise for everybody. So it was a disruptive gunnery design innovation, and it introduced discontinuous naval ship design consequences because the wood ships could not withstand this. Note the date, 1823. He produces, you know, he comes out with this. In 1841, 18 years later, he says, you know, man, this is going to do such a number on ships. Why don't we put armor plating around them, and then these shells will just bounce off? How'd that work out? He is rejected. However, they've been doing precisely that over in Korea for 400 years, 4 centuries. So the fact that we're talking about naval warship evolution in the West, we're leaving out what was going on in the East, and in fact, it was far more advanced. The Chinese put out absolutely astonishing ships. Well, something happened in 1853 to disturb the sleeping giants. The Russians took on the Turks in a port on the northern edge of Turkey in the Black Sea called Sinope. And these like 10 ships came in, and they had these Paxson guns, and they caught the Turkish at anchor in the bay. Absolutely slaughtered them. 80-to-1 fatality ratio. I mean, that's you know, 10-to-1, that's big. You know, Silicon Valley 10-to-1 advantage, well, that's a big deal. 80-to-1, wow, okay. Global consensus, everybody says, wooden ships are doomed. They're doomed now. They had been doomed for, you know, 18 years prior, but they're doomed now. So 2 years after Sinope, there was another battle, Canam. Now this is a Google map, Google satellite. Thank you. My third thank you here, okay? Up in the northern end of the Black Sea, there's this very strange peninsula in a river estuary, the Dnieper River, and the Russians had forts out there. And they had those guns, those Paxson guns. And the French, the Turks, and the Spanish are going after them. Now, do you think they're going to take wooden ships? No. They said, we got to do something else. And so France Spain and the UK build armor-plated rafts that they tow over there with ships. And they have very modest propulsion, and they park them out in front of the fort that's there. And this is a depiction of the battle. This is the only thing that's around. I'm sorry, it's blurry. But there's those 3 guys there, and this is actually one of them. This is a picture of one of them here. Okay? But think, French floating battery, Lave, 1854, 17-inch wooden hulls, 4.5 iron plate armor. Not seagoing. Had to tow it around. They blew the Russians away, just blew them away. Well, this was noticed by the French, who now were becoming annoyed with the British again. And so Dupuy de Lome goes back, and he builds this ship called Le Gloire. And it was based on a wooden battleship, but they tore off the top deck, and they put armor plating all the way around it. Otherwise, it was a wooden hull, and it had steam. Okay? And it had 4.5 inches of iron armor above the waterline. The British command of the sea noticed this, frantically built this ship. And this is an incredible ship. It's the HMS Warrior. It's moored right out there within a few blocks of HMS Victory. 14 knots. It had 600 guys on the ship. It had steam. It was an iron hull, not a wood hull, an iron hull. There was wood there, but only to secure more armor plating on. Extractable 10-ton screw propeller. 600 guys could pull up the propeller, and they could sail wherever they wanted to sail without using steam. They had exploding canonical shells. They had Armstrong experimental guns. They were rifled. They had 2.5-mile accuracy. They were very dangerous to use. They killed a lot of their gunners. Okay. Well, meanwhile, things are not going well over in the United States. There's this large bickering going on between the North and the South, and the bunch of states succeed. They form the Confederacy, and there is a boat harbor with a bunch of Union northern ships there, and one of them is this Merrimack, and they can't get it out, and they know the Confederates are going to take it, so they said, we got to destroy everything, and there it goes, right there. So what they do is they try and burn the USS Merrimack down to the water line, and they get it there, and it sinks, and they try and destroy the port, but they don't really do a good job at it, and there's like 600 Dahlgren cannons there and all kinds of ammunition and cannonballs, and so Civil War is off and running now. The Confederates had been watching all of this going on between the HMS Warrior and the Goa, and they said, we need an ironclad. So they went out and they got that burned out ship, they raised it up, they put a metal shed on it, and they called it the CSS Virginia. So now the Union is not stupid either. They finally realized we need something in response to that ship. So they put out an RFQ, and this guy says, hey, I can build a ship, an ironclad for you. No problem. He says, oh, by the way, I've got this friend, Ericsson, you know, the screw guy that was over in the UK. Well, he's over in the United States now, and we're going to talk in a second how he got here. He lives in New York, and he says, I'm going to take my plans, and this guy's really smart, we're going to check it out. But Ericsson already has a history with the United States Navy. And what might that be? Well, this is the gentleman that brought Ericsson over from the UK, and they built this ship. And there were two incredibly large cannons on this ship. There was one in the front and one in the back. Ericsson built the one in the back. The other guy built the one in the front, and Ericsson said, do not do that. This gun will explode. This gun will kill people. Do not do this. He did it anyway. So how did it work out? It exploded on a very important demonstration. It killed the Secretary of the Navy. It killed the Secretary of State. It killed about 8 other people. It would have possibly killed the President of the United States, except he was down below on a lower deck taking care of a woman that was sick. So when I lectured at Stanford, I looked at the students and I said, for those of you in the MBA program, here is your takeaway. It's not good to get blamed for killing your only customer, right? So the Navy knew Ericsson. He got slimed. Here's another lesson. If you're in the arena and you're doing hard stuff and there's risk and there's uncertainty, but you're doing the right thing, you are fair game to get slimed, and you need to know it. So when you get slimed, it means maybe somebody really likes your work, but they're not going to admit it. You know? So what happens? Bushnell goes back to Ericsson. And Ericsson says, looks good, but oh, by the way, would you like to see this design that I proposed to Napoleon when he was fighting the British? And he says, yeah, sure. That is the design. Sloped armor everywhere because it's all curved. And it was rejected by Napoleon because he said it's going to cost too much and you don't have many guns. And what he didn't understand was the guns were in turrets. When the guns are in turrets, you don't need many of them because you don't have to point the whole ship to get your guns in line. You sail along and you just point the turret and you shoot, and then you just shoot and shoot and shoot. So you get to shoot far more often. Well, they build this for the United States Navy, the Union Navy. Notice the similarity. Okay, it's not as sophisticated. They didn't have as much time, and it certainly wasn't perfect. But it was called Ericsson's Folly. The reason for that is people said it would never float when it was launched into the East River. So Ericsson stood on deck as it launched down the ramp. Good man. Very innovative, great place, great anchor, tucked away. There's one of his great propellers. That's the actual one. The thing did sink. They found it about 10 years ago, brought it up, and this is the actual propeller that was on it. And it had this turret. Now, he often gets credit for inventing the turret, but that is false. He actually had to take a patent out because there was prior art and there was precedence, and there was another fellow over in the UK by the name of Copperphipps Pose. And he's a very interesting guy in his own right. And we talked about a ship that was out in, Denmark that flipped over in the bay, and Copperphipps Pose also did one. He built one and it rolled over, and everybody except like 16 people out of 300 died. So the ship with the metal shed on top gets out first, unchallenged, and it destroys 2 of the ships that are in the Union blockade. Catch on fire. Now, what is the problem here? Well, there's a couple. One of them is this, the wood ships. But the real problem is they didn't have steam. They couldn't get away from this thing. And this thing could only do like 2 knots or 3 knots, and it took 45 minutes to turn around. I mean, this thing was, aquatically and nautically speaking, not to be purgative, but it was a stinking tub of goo. So CSS Virginia comes out the next day, and lo and behold, USS Monitor is there. And this is the depiction of the battle there. They take on one another. It's a stalemate.
What did you say? Do the Monitor or the other ship?
Oh, this thing here was ridiculous. It was absolutely, this is the CSS Virginia. That was a ridiculous, that was a kludge. And one of the takeaways here.
That had been the Merrimack.
That had been the Merrimack. Yeah, and the Merrimack, by the way, has 2 spellings, one with a K and one without. So you'll see that when you go search. The deal is that sometimes, like when you're really under pressure from an adversary, you don't have to engineer the best thing. You can kludge something together that can hold together for a while, and you can get a stalemate, buying you enough time to go around and do the right thing. So it was a stalemate, but the Monitor had only been using 50% of the powder in its shells that it could have used. And why was that? Because of that explosion 18 years earlier. Nobody in the Navy was allowed to use more than 50%. So the takeaway here is maybe it's worthwhile to go back and review your corporate procedures and rules once in a while. Because if he had been shooting 100%, he probably could have taken that guy out. So here it is after the battle. You can see the dents in the metal from the actual battle itself. They only met once, and you see these guys out there celebrating and lounging, and if they'd been able to have a Corona or one of these great juices you've got over here, a vitamin drink, they'd be out there just lounging around. Looks like a great tour, doesn't it? Guess what? It's not. It gets up to 165 degrees inside that thing. They are absolutely miserable. They're not even particularly mechanically sound. They're certainly not seaworthy. And there were actual discussions on, we may have to scuttle this whole thing if we try and fight for like 5 hours and we run out of salt pills and water. We don't want this to fall into enemy hands. So it's a kludge. Well, soon thereafter, they're everywhere. These are Union ones. The top one is on the Mississippi River. The lower one's out over on the East Coast in Washington, D.C. The Confederates have them also. In fact, Confederates have a problem because they don't have a lot of iron. So they're stacking, cotton bales and things like that around any kind of armament. So they're kludging the kludges now. And what you find is both sides find these are very difficult to build, and they're only for smooth water. They're not seaworthy. The reason why they're difficult to build are for different reasons. In the Union, everybody had been building wooden ships. And so they say, you need to rivet this iron plate to this iron plate. And the guy with the wood planer, goes, do what? So it was a new technology. It was alien to everyone. Over on the other side, they didn't have the iron, the raw materials. So is this the end of wooden ships? Not exactly. There's an expression, quantity has its own quality. You don't want to bet your company or existence on it, but here, this is a battle going on in Charleston Harbor. CSS Albemarle, a very well-built ironclad owned by the Confederates, and it is being jumped by a wooden sidewheel paddler there. And if it had hit just a little bit farther to the forward, it would have pushed that gun port over water. It would have sunk like a rock. But it didn't. And in fact, the wooden ship was severely damaged and maybe ruined. So sometimes tactics and quantity can trump quality. Well, the war ends, and the United States Navy now has come up with this monitor, and they understand steam now, and they understand iron. Guess what? They regress back to the days before the Civil War. They pretend like it never happened because the threat's gone. They're building really clunky wooden ships, no steam in them. The ships under sail go 3 to 4 knots, which means you could almost walk as fast as these things on the water. And when it comes to coal use, we're not allowed to use coal. Even though they had steam engines, if a captain used coal, he had to write in red ink in the log why he was using coal. It was reviewed. And if the reviewers decreed that it was an unwarranted application of coal, guess what? The captain paid for the coal out of his own pocket. Now that's an incentive. Notice that in 1864, the fastest ship in the world had been built already by the Union. It was called the Uss Wampanoag. Incredibly brilliant engineer by the name of Escherwood did it. He was very high strung. These are his design points: long tapered hulls, gears and a steam engine. He had four steam engines there. He had late cut-off piston stroke, which improved the efficiency and the power delivery of the steam engines, improved on Ericsson's boats. And guess what? Nobody liked him. This is his description. The only way you're going to find my ship is by just finding the burning hulks that it leaves behind. Okay? So in 1899, there's a commission, and the bottom line is they scrap it for 3% of the value, first before gutting it. They haul it off down the river, and they cut it up, and it's gone. This was the greatest, fastest ship in 1864 in the world, right? He got slimed. Well, back on propulsion again, there's this fellow named Sir Charles Algernon Parsons over in the UK, and he, like many other people at the time, was very fascinated by this concept of the aerofoil. And it was this thing from ancient Greece where you put water into this tub and pipes came up and you set a fire underneath it and it spun this ball. And he said, rather than make a ball spin, why don't we take this jet of steam and put it into a windmill? If we put it into a windmill and maybe a whole bunch of windmill blades, we can turn the shaft and we can connect it up and we can generate electricity and stuff. And sure enough, it's called a turbine. He applies the technology, the first person to do it, 1894, to this small boat called the Turbinia. And he had one very powerful steam engine in there, and he was real pleased. And what he discovered was he could only go half as fast as he thought he could go. And the reason for that was he was the first person to try and transfer that much energy off of a small propeller to water. And he experienced an effect called cavitation. He discovered it. This is where it happened, right? So what he did is he ripped out his engine. He put in 3 turbine engines. Each had their own propeller shaft and 3 propellers per shaft. And there it is. That guy was hot. That was the real deal. Fastest thing on the face of the earth on water. He went out, he disrupted a ship day with Queen Victoria there. There's nothing the British could do to catch him. He could run circles around the guys that were trying to get him. Well, about 1910 or so, there's this tremendous turmoil on materials, steel and steam and engines and guns, configuration of guns and things like that. It's known as the Age of Uncertainty. It all came to a screeching halt about 1910 or so, 1906, with this ship here. It's called the HMS Dreadnought. And what made it so special was steel construction, turbine-powered, 1 caliber gun. You don't need a bunch of small guns because you shoot at the guys far away. And if you're good, you take them out. But guess what? They weren't good. They only had 2 to 3% accuracy. So he hires Sir Percy Scott, and he develops, who had developed this thing called continuous aim firing. He jacks it up by 30, 40% in accuracy. And meanwhile, he trains this guy, William S. Sims, in the United States Navy on how to do it. So Sims, he understood that the Navy was in complete archaic decrepitude. Brazil had a better Navy than the United States did. So he gets together with his buddy, Teddy Roosevelt, Secretary of the Navy, and they say, we're going to build a whole new fleet. And guess what? No outsourcing. And when they said no outsourcing, they meant all the way down to the rivets, and including the rivets. They built their own rivets for all of these ships, and so they did it. He was very good. Sims was very good. Homer Poundstone, one of his colleagues, had already proposed a ship very much like the Dreadnought. He had been ignored, right? He got continuous aim firing going, and it was vigorously resisted by the Navy. If you read Edeling Morrison's Men, Machine, and Modern Times, great story about it. And Teddy Roosevelt was then president, so he just wrote a letter to Teddy Roosevelt. That's called top-down support, which sometimes is imperative when it comes to innovation, right? Accuracy went up. Sims himself on his ship scored 100%. We talked about getting slimed a couple of times before. Sims got slimed. There was an accident that occurred in a turret on the USS Missouri. They said it's all your fault with all these newfangled techniques and firing mechanisms. And Sims's response was, don't store propellants in the hallways, guys. We've been talking about this for 15 years, right? You know, so the ship blew up. Okay. So, but this is it. This is the USS Alabama sitting out in Mobile Bay. It's my wife there. And if you look at that sign, that's the details, right? Muzzle velocity is 1,570 miles, and they can put it on a football field from over 20 miles away each time, every time. Incredible fire control, despite the fact that the Japanese had bigger battleships, excuse me, we would have blown them out of the water in one-on-one confrontation because we had that accuracy. We could fire over the horizon. They wouldn't even be able to see us. So, you know, so best battleships run. There were 4 that were better than this particular class battleship, but this is good. Yes, sir?
How do you do over-the-horizon targeting since do you need to have planes to do targeting for you?
How do you do over-the-horizon targeting? They did have radar, they had computers, and sometimes they did have spotter planes.
Okay, this is...
Trust me, they could do it. We got a lot to go. No, we got a lot to go, but come get me later. But they could do it. In World War II, they had them. But is it really supremacy? You see those guns there? Those are anti-aircraft guns. Those are guns also used to protect the shore troops. So, is it supremacy? There's 2 nopes here. Here's nope number 1, John P. Holland, father of the submarine. Right? Come a long way since Mr. Bushnell's day in the Revolutionary War. In fact, how far did it come? You see this ship here, the HMS Barham battleship. It was out in the Adriatic at the beginning of World War II. German submarine got it with 3 torpedoes. It rolled over, and its magazines exploded. That's 860 guys going away. This is very serious. The Germans had listened. Sometimes it's good to be agnostic as to what the source of the facts are. Nope, number 2. General William Billy Mitchell, air advocate, land-based bomber air advocate, incredible disturber of the peace. And all moribund, stagnant organizations need disturbers of the peace. Those are real medals given from various countries, various kings and queens and authorities and things like that. And what he basically said was, you give me shore-based airplanes and I can destroy battleships. Right? 1,000 planes in cost equal 1 battleship. You give me some of these, I put them on some of those, I can sink a battleship. The Navy said, no, you can't. And Billy said, yes, I can. And that argument went on for about 3 or 4 years until Congress said, you know, we're looking at all of these allocations and appropriations for battleships. Navy folks, you are going to do this test. So they tried to softball it, and they tried to slime him. How'd it work out? Well, we're going to see in just a second. But Sims, remember the big thinker on Sims? Back in 1909, he agreed with one of the Wright brothers that said, from an airplane, you can't hit anything. So he says, battleships are safe. In 1919, he says, man, all the airplane-carrying ships couldn't make an attack on a foreign country. Right? We're going to see an evolved position because this guy is a critical thinker that listens to the fact. So here's the test. You guys are smart. I'm sure there's some judgment calls on whether or not this battleship went down or not. So I'm going to leave it to the audience here. I'm just going to silently step through the slides. Ooh. Ooh. Oh. Oh, my goodness. Whoops. Oh, auf Wiedersehen. Now, what do you think? What did the Admiralty do that were on the observer ships watching this happen? What was their reaction? Does anybody know? They sobbed into their handkerchiefs. And why did they sob? Because they were in love with the way that they were doing things to achieve an effect. And that way had passed. Don't fall in love with the way that you do things, right? What was the official Navy reaction? It doesn't make, I think it was moored, it was clear air, they weren't shooting back, it wasn't moving, you can't do it. Okay, so the controversy remained. So Billy Mitchell puts out a book, 1925, on wing defense, and these are the front end papers, full of political cartoons that had been tracking this deal. I actually went on a Liebers and I got a copy of the book. This is my favorite cartoon here. Billy Mitchell running in, boss, your house is on fire. And the Army Department says, you're fired for waking me up. Meanwhile, the War Department and the Navy Department are snoozing like babies as the sky fills with airplanes. At this point in time, the United States, I can count them. How many operational airplanes did they have for war? 6. The entire United States.
What year was this?
Oh, 22, 24, had 6. So he's willing to, he paints a target on himself. There's an accident on a blimp, and he puts out a press release talking about incompetency, criminal negligence, and almost treasonable administration. So this is insubordination. Right here. President Calvin Coolidge orders a court-martial. Now, are you guys familiar with Coolidge? Probably not all of you. Let me give you a couple quotes from Coolidge. Familiarize, acclimate you. When large numbers of men are unable to find work, unemployment results. Here's a better one. When it comes to aircraft appropriations, why can't they buy just one airplane and take turns flying it? This guy's progressive. So Calvin, he has it. So this is the court-martial. He's going down. It doesn't make any difference what anybody does. He is going down for the count here, right? Admiral Sims actually comes and testifies on his behalf. This is another one of the end papers where he says, I'll tell the world that an airship can sink a battleship, and the other little ducks, which are the admirals saying, silence him, not a word, right? He talks about the evolution of the airplane and how it has displaced the supremacy of the battleship. Here is the big quote, the battleship is dead. Those are pretty strong words. That's in March 1922. Okay? So he says, if ships show up with a bunch of these airplanes on them, the best place for our battleships are as far up the Mississippi River as they can get away from the ocean. Good. John Maynard Keynes, great economist. When the facts change, I change my mind. What do you do, sir? Congressional testimony. And of course, there is the time immemorial Machiavelli quote about the difficulty of introducing a new order of things and change. So, the trial's going on. He's got all kinds of press support. These are cartoons here. Everybody's shooting at him in the Army and the Navy and the War Department. A joint resolution in Congress gets announced. Doesn't make any difference. Now, here's where the money comes involved here. Okay, are you guys history buffs? History? Okay, all right. So you got $5 questions. So we're going to see who's lucky. But there's a lot of smart guys here. So if you You want $5, you got to yell out your answer quick. Now, don't think too hard. Okay, ready for this? Surprise aerial attack. Launched from aircraft carriers, naval fleet at anchor, shallow harbor, torpedo bombers, very successful. Come on. Come on. You guys are just so smart. Is there some part of the word no that you're not familiar with? All right. No. The one I'm talking, your name? Dan. Thank you for suffering and pain with me here. That's the ship there. No, it was actually in Toronto. No, you get up here. Come on, no, you get. You're a nice guy. You're gonna. Okay, partial credit here. All right, you get up here. No, you're my victim today. Toronto, Italy. This was a year before Pearl Harbor. So the British did this. How'd they do that? Well, those guys, little silk-covered things, and they blew the Italian Navy right out. So you showed guts, Dan, and I'm really proud. I'm going to give you partial credit. Okay. You stay here. Okay, but you got to stay here. Okay, so I'm going to give you info marker. Here we go. Okay. Name that time. Okay. Are you ready? Right? And you can have them help you. Do you have a friend out here that you trust? Dan doesn't have any friends. Okay. Here we go. When was the first carrier-launched aerial torpedo attack against a naval fleet in a home port proposed? When was it? Do you know? Take a guess. Come on, Dan.
1930.
Good guess. No, it was 1918. It was World War I. And we're building to a point here, all this pain here. And you're being such a good sport here. Okay. So it was 1918, all right? And it was actually proposed by a guy who was very difficult to get along, British naval aviation guy, in 1914. And the Italian one that we saw on the previous slide, they dusted off this plan. And this plan was to go sink the German fleet, High Fleet, that was at anchor in a river. It was bow to stern in a river. Like bring the torpedo planes, you can't miss. And they wouldn't have. So, here you go. Yep. Okay, here we go. Okay, this one here. Let me, here. Okay. 20th century Japanese naval forces launched a devastating surprise attack that destroyed a large nation's Pacific fleet and declared war after. What was the United States reaction? What did they do?
Entered the war.
I was actually talking about 1904, Port Arthur, you see? So with a little bit of social engineering and a willing guess, thank you very much, Dan, you've been absolutely supreme. Yeah, give him a big hand, right? Okay. All right, so there's no way that you guys probably could have got this. There was a distinguished engineer out of the Dutch Royal Navy from Sun that got these answers last week when I gave them. But they actually liked it. So think about it. How is it that Pearl Harbor happened, right, when there'd been a surprise attack that was admired by the United States, right? That it was an attack in a shallow harbor, carrier launched. Like, what were they thinking? I can tell you what they were thinking. They were thinking that, we're the smartest guys on the face of the earth, and none of us can figure out how to do this, so therefore nobody else can. Bad answer. They thought they were going to go attack the Philippines, and they didn't do it.
So what did the carrier launch in 1904, since the airplane was only invented in 1903?
No, it wasn't 1904. It was 1940. It was proposed. They couldn't. See, it was a trick question. It was proposed in 1914, but they couldn't do it logistically, and the war ended, and they kept the plan secret, and then they used it in Toronto in 1940. It was proposed. In 1914, no, the airplane was around like in 1904. It had been around 10 years. That's correct. See, now it's socially engineering here. There's no air in here. Oh, yeah, there's no air here. They came in with ships. They shot them up. Yeah, I cheated. Yeah, I'm not a nice guy. I'm just a presenter. Okay. So there's nothing new in the world except the history you do not know. And there's a lot of history you don't know. And that's one of the reasons why I like Google, and one of the reasons why I like your digital book project. Okay, so meanwhile, back in 1924, Billy Mitchell had said Pearl Harbor attack will commence at 7:30 on a Sunday, and the Philippines will commence at 10:40 in the morning. How did that work out? 7:55, this is an actual picture from a Japanese fighter or observatory plane here. And these guys were really good. These Japanese guys, these guys were good. There's no doubt about it. It was beautiful. the torpedoes that the Americans couldn't figure out how to build? Well, Japanese put stabilizing fins on the back so they wouldn't try and drop down to 100 feet and then come back up and ride shallow into the ships. And they put nose blocks in front so that when they hit, the water hammer effect would destroy the wood and they would just go straight in. These guys, beautiful. Notice this. Can anybody identify those things that are circled? Those are fuel tanks. And they were supposed to be destroyed on the third wave that never came because they didn't know where the carriers were. American carriers were not in Pearl Harbor. That should have been target number one. If they had hit target number one, that is target number one, they would have taken out the Pacific Fleet. You don't kill an aircraft carrier or a destroyer by sinking it, you just take its fuel away. That was the fuel. It was all intact. They got away. So 3 days later, remember a ship can never sink a battleship? HMS Prince of Wales, out of Singapore, trying to do some kind of rescue mission. It was destroyed at sea during violent evasive maneuvering by the Japanese, aerial attack bombs and torpedoes. That's the attack. That is another Japanese picture taken of the attack sinking the HMS Prince of Wales and one of its sister ships. These guys were good. They were really good, no question about it. So the Germans had paid attention for the submarines, and Japan had paid attention to Billy Mitchell and Toronto. Those were the key things. They were right on top of Billy Mitchell sinking of that battleship, and when Toronto happened, they said, bingo, now we got him. I think Billy Mitchell's reaction was, anybody tell me? What did Billy Mitchell think about all this?
Why didn't you listen?
Why didn't you listen? That's a good one. Anybody else? Come on. No guts, no glory, guys. Huh?
Forfeit his award?
Yeah, it's good. Okay. Well, it turns out he was dead for 10 years. So the takeaway here is when you get slimed or when your destiny is not fulfilled, sometimes the dragon wins. Sometimes it does. But I'd rather die in the battlefield than in a rocking chair. Right? So, every society honors its live conformists and its dead troublemakers. Great quote. So, this is a picture that I took about last summer before. It's the USS Ronald Reagan, nuclear aircraft carrier. Distant warfare, they don't see the enemy's few guns. It's considered by many to be the supreme warship. So, Sims and Mitchell were approximately right. Keynes again, it's better to be roughly right than precisely wrong. Okay? But, guess what? Just like the wooden warships had outlived their usefulness, we've got supercavitating torpedoes, we've got exocet missiles, we've got land-based things, we've got Iranian diesel submarines that are extremely quiet because they have learned from the Japanese how to build silent screws. We have very inexpensive launching machines, and we have cruise missiles. And some of them can be tactically armed with nuclear weapons. So, evolution is not an event. It is a process, and it doesn't end. So if we look at the warship, the early wooden warship, the battle went from 2 dimensions on the surface of the ocean to above and below, which makes it 3D. These are some of the forces that were working on it to evolve it. There were also social forces going. Above and below, there's the first warship airplane takeoff, and here's the first landing. Things in red, those are sandbags with ropes tied behind so they could snag between them so they could snag a tail hook in and stop. That guy was dead 6 months afterwards from all of this. Top 10 closing observations. Be careful what you decide not to do and offshore and outsource. You can liquidate your future. The British did it a couple times. Just because you can't design something doesn't mean that the adversary can't. Okay? Tactics sometimes. Reformers can be very abrasive. So you have to decide, do we want a politically correct, homogeneous group, or do we want some guys that are really going to shake things up and bother some people? And it's a balance that's going on in here. Okay? Just because you're passionate about something does not ensure correctness. We're running out of time here. Remember Lux Roll? There was a commerce raider that went around the world, the CSS Alabama. They didn't have the Wampanoag, right? But they caught it in port. And with this other wooden battleship, there was a battle. The SS Alabama was out shooting the ship, but the killer shot that went into the stern post of the Union ship did not detonate. And there it is. And that's why the Union won that sea battle. Right? Lucky? You bet. I'd rather be lucky than good. This is my bibliography. And right here, thank you, Google, are digitally scanned books. The facts from the Siege of Gibraltar came out of an encyclopedia published in 1895, University of Michigan. You guys scanned it, and all of a sudden it was there one day, and I got all the facts that I wanted. Thank you very much. It's been a privilege being here. Thank you very much. And anchors away, guys.